Just want to do a quick little overview of some inverse trig. And a while back, we defined y equal to arc sine of x. And what you could do is you could take the sine of both sides and get sine of y equal to sine of the arc sine of x is just x. So in doing that, we can take the derivative of both sides and get 1 equal to cosine y dy dx. Solving for dy dx, I get dy dx equal 1 over the cosine of y. And y is arc sine of x. And you might say, well, how do you deal with the cosine of the arc sine? We haven't talked about that. We haven't. We've sung about it. Make a triangle. I'll let you hum that at this time. dy dx is going to be, if this is theta, and arc sine of x, sine is x over 1. Pythagorean theorem, 1 minus x squared, square root. So then all we have to do is say it's the cosine of this triangle, which is square root of 1 minus x squared. That is the derivative of arc sine. And if you do arc cosine, all that happens is when this is changed from a sine to a cosine, you're going to get a negative here. And everything is going to be the same, except it's going to be negative 1 over the square root of 1 minus x squared. So with this in mind, what you can do is you can take this derivative and you can say then the antiderivative of 1 over the square root of 1 minus x squared is going to be equal to the arc sine of x plus c. So that looks good. But what if you don't have a 1 here, you have a squared, a constant squared. Just like the x is squared, you have an a squared dx. And you want to find out what that antiderivative is. A little bit of work, but not too difficult. What you're going to do is you're going to say, all right, I'm going to factor out an a squared and make it 1 minus x squared over a squared. This is still a squared minus x squared. Then you go below this and you say this is going to be 1 over the square root. The square root of a squared is a times the square root of 1 minus x over a quantity squared dx. Now I'm going to do a u sub with this. I'm going to say that u is equal to x over a. See how that x over a? And then the derivative of u, 1 over a is a constant, times 1 dx. Now this is kind of cool because we can just say that this is the same as 1 over 1 minus u squared, square root, and this 1 over a dx is the same as du. So one more in-between step here. You have 1 over 1 minus x over a, quantity squared, square root, and then you have, in green here, 1 over a dx. The green is du, and what's underneath here, well, excuse me, what's in parentheses is my u. Okay, so the antiderivative of du over square root of 1 minus u squared is just going to be the arc sine of u plus c. And u was x over a. Notice we have an x over a included here. And this, an example might be integral of 5 over the square root of 9 minus x squared dx. What I would do first is I'd pull the 5 out in front, so you get dx over 3 squared minus x squared. Pick on your a and b. A is just going to be 3, and u is going to be x. Just use the formula above, and the formula above is the antiderivative of dx over square root of a squared plus x squared is just going to be arc sine x over a. And that is going to be 5 times the arc sine of x over 3 plus c. So there's how you would do an antiderivative of 1 over square root of 1 minus x squared. That's using arc sine. So remember, this is antiderivative is going to involve arc sine. But another common one is the antiderivative of 1 over x squared plus 1, which is the arc tangent of x plus c. Now this one occurs more than any of the other ones, arc sine, arc secant, and you definitely want to memorize this one. And for the arc tangent, I'm not going to derive it. We've done it before, but I can leave that up to you. You start with y equals arc tangent of x. So if you took the tangent of both sides, the tangent of y is equal to x. And I'll let you go through, make the triangle, and do all that, but you're going to get 1 over x squared plus 1 dx. So now what I want to know is what happens when we throw in 1 over x squared plus a squared. This is a little bit more interesting, a little more challenging, but you'll see a lot of similarities. I'm going to take out an a squared in the denominator and leaving x squared over a squared plus 1. Then u is going to be, if we rewrote this, dx is going to be 1 over a. 1 over a gives me a squared. Do you agree with that? Ugh. One over a times the integral of 1 over a x over a quantity squared plus 1. Let me try this one more time. So it's going to be equal to 1 over a times the integral of 1 over a times dx over x over a squared plus 1. Okay, so we're going to let u equal to x over a again, and so the derivative of u is going to be 1 over a dx. Well, we have that, don't we? We have the 1 over a dx. It's right here. And we even have an extra 1 over a. Hold on to that extra 1 over a. So working this out, it's going to be 1 over a. This yellow part is the same as du over x over a squared is u squared plus 1. And we said that du over u squared plus 1, or 1 over x squared plus 1, was 1 over a arc tangent of u, which is x over a. Notice that there's an extra 1 over a for arctangent of x over a. So let me just show you one real quick. So if you were to take the antiderivative of 9 over 5 plus x squared, there, that's a common one. First thing you do is pull out the 9 and get dx square root of 5 squared plus x squared. And then you'd pick on what the a is. A is the square root of 5. And u is going to be my x. So this is 9 times, of course, du is just dx. You'll have du over a squared plus u squared, or a squared plus x squared, if you want to just call it that. And then this antiderivative will be 9 over a square root of 5 arctangent of u, which is x over a, which is the square root of 5. So that's how you handle the arctangent. So one more time, the integral of dx over square root of a squared minus x squared is going to be equal to the arc sine of x over a. No 1 over a out in front. Then the antiderivative of dx over a squared plus x squared is simply going to be 1 over a arc tangent. Did I just say simply? X over a plus c. Notice that there is an extra 1 over a for arctangent. There's no 1 over a in front of arc sine. And then the other thing that I would suggest is for each one of these, list what a is, list what u is. And that'll just help you figure it out. And you could, instead of x, put u's in here as well. One more quick integration technique. If I want to integrate 1 over x plus 1, what would you do? Well, you would probably let u equal to x plus 1. The derivative is dx. This is probably just going to be the natural log of x plus 1, isn't it? Plus c. Okay. But what if somebody put an x up here? What if you have x over x plus 1? Now, if u is x plus 1, the derivative is dx, you've got this extra x, and you're not going to be able to take this integral. You can't use u sub for this one, because you've got an extra x. You could do integration by parts. It'd be weird and messy. There's a much better way to do that. And the way you do it is, what is 27 over 7? Well, what you do is you think of this as a doorknob, and I call this turn the knob. I know, strange. Turn the knob, you turn the knob this way, and when you divide the 27, when you turn the knob, the 27 falls in here, and the 7 stays out here. And 7 times 3 is 21. You reduce it by 21 and you get 6. And so you have a remainder of 6. But we don't say a remainder of 6. We say it's plus 6 sevenths. And so now we've written 27 sevenths into 3 and 6 sevenths. What that means to our integral is we're going to take x over x plus 1, and we're going to turn the knob. And in the radical, the x falls in, and outside is x plus 1. X times 1 is x. 1 times 1 is plus 1. Now when I subtract this part, you're going to get x minus x is 0. 0 minus 1 is negative 1. Remainder 1 really means minus 1 over x plus 1. Now that's a good thing because I can. So what this means is that instead of x over x plus 1, we can replace it with 1 minus 1 over x plus 1. That's interesting. You mean this is the same as 1 dx minus the integral of 1 over x plus 1 dx? And I can integrate 1 as just x, and I can integrate this as the natural log of x plus 1. And so you can integrate x over x plus 1 using turn the knob. That'll help you with your lab. So take out the lab, and the instructor will bring out your lab write-up format. You can see how to tackle those. See if by Monday you can find all those antiderivatives, and more importantly, start to find a pattern for those. With a lab like this, you're going to take all of these antiderivatives, and then you're going to do this with the constants, A and B, and you're going to see if you can find generally antiderivatives for each one. But what I'm really interested in is that you can eventually find some patterns. And the patterns are going to help you recognize when to use turn the knob, maybe arctangent, maybe u sub, maybe natural log, who knows. So work on that for Monday. Finish all 14 of these. You can work in groups of 2 or 3.